put a note on there on the. So it's my pleasure to introduce the first panelist for this session. So Jeannie Holmes, who we actually have some background in common. It turned out, which we were in we know the same people. Yeah, it's a small world. But now with the city of Los Angeles, with one hat, you have multiple hats, I guess. But in particular, what can data science, geospatial data science, do for a municipality? And I've heard we've got some interesting things you're going to talk about. So.
Great. Thanks, everybody. I also am short, but I don't need it moved. I'm fine. It's okay. I'm used to being short. I've been short all my life. So I want to focus in specifically on the idea of how do we generate a new generation of data scientists, not just what we're doing in LA, although clearly I'll talk a little bit about that, but really want to just sort of bring in a lot of the background I've had before I came to the city and try to understand how we are doing something different in Los Angeles that may or may not be useful for others. But I think it's particularly pertinent for the fact that we live in a completely dynamic time for the way in which a lot of fields are coming together. So these are some of the technologies that we're using in LA related to data. And I'm sure that you can see some things on here that maybe relate to other things we've discussed or things that you do at your organization. Some of the things we haven't talked about at this workshop are gamification. Gamers in the group? No, seriously, no. Like World of War, like, okay, so I'm a big gamer. World of Warcraft, Assassin's Creed, like Call of Duty, okay. But gamification is super addictive, and it's a great way that I'll talk about on how we get our youngest citizen scientists engaged with the city and the world around them. And then, of course, virtual and augmented reality. Okay, great. All right. All right, so another way in which we start to change the experiences, that we start to understand how people want to not just have the world around them change or like a fantasy world, but really how the future of the city can be imagined together. And so we actually learn a lot about how people design things in SimCity, for example, and how they want to have, sort of new generations and new ideas about how a city should be designed, not all of which are actually physics-based. But it's really interesting to think about the concept of taking a roller coaster to work. So we talked about all these amazing things, and we all envision that we've got this team of heroes, right? Who has a data hero in their organization? Okay, who has data sidekicks in their organization? Okay, because every hero is only supported by all those sidekicks, right? So Batman is not really Batman without Robin and Alfred. So let's think about like the fact that there's a whole infrastructure to these people who we often think about, oh my gosh, they've made this amazing breakthrough. And so we call open data a team sport in Los Angeles. And so we have, and it took me forever to get the city council to approve. The mayor and I put together an idea to have a city data and predictive analytics team that really looks across all the city departments for big issues, much more than just our chief data officer kind of looking at policies and aspects around data, but really how do we look at harnessing all of that data, synchronizing it, putting it into a data lake, and being able to really change the face of how we use data at the city. And underneath this are some very basic values. And number one for us is equity, because we all have smartphones, we're all data savvy, we're all very data literate. 50% of the households in Los Angeles, in some of our neighborhoods, don't have internet access. So the idea of talking about data and data literacy and digital services needs to really take into account the fact that we have this huge data divide, and we have to significantly work on data inclusion. We are also working on 2 documents that are in draft stage, and we're about to go out to public review. One is a code of ethics. So we've talked about this a little bit today, but I thought it was super timely because I was in the back of the room madly updating it. So our code of ethics is for our ecosystem of developers. That is a rule of series of guidelines by which we have to behave and the values in which we uphold in order to be able to create systems because of inherent bias, unintentional bias, unintended consequences. And so just because you've been directed to create a system, just because you've been directed to grab data sources, you also have a responsibility, because with great tech comes great responsibility. And we have to make sure that everybody in that ecosystem speaks up whenever they think there may be an issue with the consequences of what they do. The third aspect, and the other piece, is a digital bill of rights for citizens, how they can expect that they are monitored. Who was talking about monitoring earlier today, right? You're not just monitored in the UK, you are monitored everywhere, right? If you're carrying a cell phone, you are monitored everywhere. And so we are working on this digital bill of rights for what citizens can expect as they move, work, play throughout Los Angeles, and what kind of sensors are in our network. We also work a lot around inclusion, which is making sure not only that we talk across the digital divide, but that we are diverse teams. So our teams are staffed with gender equity across the spectrum. This is Los Angeles. So we think about, a lot of diversity there. We think of age diversity, ethnicity. 220 languages are spoken in our city. We need to start thinking about representation. And co-learning is an important aspect as well, where we want to take young people with new ideas and partner them with, say maybe older, more entrenched cities. Is more serious? Is that what you said? Experienced city staff who maybe haven't been exposed to some of these new technologies, but do it in a way where everybody learns together and it's not judgmental. We are grateful for all of our city staff and for all of the work they do every day. And if they haven't been back to school recently, it's not anything that we hold against them. We want to make sure everybody learns together and that becomes an empowering experience. So we start young with data science. We have programs with Girls Who Code, which is an amazing organization. If you aren't part of it, you should sponsor a local group. We have over on the far side, you see 3 girls looking at their phones. They're actually playing Discovery Agents, which is one of our gamifications for helping kids explore the parklands. LA is a super biodiverse place. We have mountain lions and bears and cougars. We just don't want the kids to actually interact with them. But we want them to catch augmented reality versions in our parks and understand more about the flora and fauna. We see a young man over there working in a robotics lab at our public libraries. We have 37 maker spaces, and you can see sort of our multi-generational learning activities going on there. And then we just opened up our Octavia lab, named after Octavia Spencer, who is one of the most amazing Black women American science fiction writers. And she did a lot of her research at our central library for her books. And Octavia Lab has 3D printers and scanners and podcasting stations and all kinds of amazing new technology, totally free to anybody in Los Angeles, young or old, to come in and learn these. And we have all these sorts of teachers in space so that people can start to cross that digital divide. And then we also think of data science as part of our ecosystem. And this is Hack for LA. Have you heard of Code for America? Okay, so our local brigade is called Hack for LA. It's the most active brigade in the country. We meet 2 nights every single week. City and county are there, as well as a lot of local technologists who work together to hack on using open data, different kinds of solutions for the neighborhoods. And then really kind of starting to bring a lot of this together, I founded a data science federation. So I've been a professor at UCLA for 25 years, and my students, like for those of you who teach, you want your students to have meaningful assignments that inspire them and generate really a lot of interest in the field. And then we use these data problems where the data is, just the same data that every other set of students has used before them. And the same outcome is just this classroom assignment. And so instead I said, what if we can solve this problem by having students make real change in their environment, like in their neighborhood? What if we could have them do homework on their hometown? And what if we can combine that with the fact that our city really needs to have different changes and this co-learning experience? And so what we've done is created a partnership with 18 different universities and colleges in the local area between California and Arizona, and then partnered those with 88 other cities that we've expanded to. And students and professors each semester sort of bid on or suggest different programs that they would like to do, and that's based on what our city departments have needs of. So right now we're doing a ton of programs around the zoo. We are doing programs with our LAX airport. If you've flown into LAX, it's not about the traffic at the airport. And so students have a chance to make a real difference. And then we have this pipeline for job placement in the city, because really what I want to do is hire these young data scientists into city government, or at least get them exposed to government data and how they can be part of their future government experience. They work on all kinds of different projects. Each year we do about 20, 25 different projects, everything from homelessness to earthquake early warning, to taxation issues, to economics. And we provide all this data on our open data portal. So shout out, like, I think I partner with almost everybody in this room. I'm just like so surprised. So shout outs to Esri, AWS, Uber, even if we're having a little disagreement right now. Normally we're best of friends. Let's see, university partnerships, USC was here, the California Public Utility Commission, USGS, NGA. You're like all my family. So, so we bring our open data through our open data portal, but we use lots of data or services or support from lots of you in actually making this happen. So one of our programs, for example, that the students have worked on, we just won a $1.3 million grant from NASA. It's called Predicting What We Breathe. And so the way that we pull all of these pieces together, I know you thought it didn't really make sense when I talked about kids and citizen science, but Predicting What We Breathe collects data from satellites, airborne instruments, and ground data sensors from our Internet of Things across the city and across the region, and then federates that data in a way that helps us to start to use machine learning to create predictive analytics about the quality of air. And we are partnering with other mega cities around the planet to look at characteristics that we share to see if we can evoke patterns from satellite data that may help us to understand things that are happening on the ground and move by, for example, where they may not have as many ground data sensors. So it's a pretty interesting experiment. Many of you know the program sponsor for this, Mike Little, from the NASA AIST program. And we have lots of different partners on this one. And then Shake Alert LA was one we rolled out last January. And this is an earthquake early warning system. It gives you up to minutes warning that you will about to feel shaking of an earthquake in Los Angeles. And so we have over 1 million users, which is a lot for a little city app. And we partner with the USGS Shake Alert system, which has sensors up and down the West Coast. And the trick here was really the technology and the latency and the network, but it's a lot about behavioral nudges and behavioral science to get people to be safer during an earthquake. And of course, we have autonomous vehicles on the streets of LA. And thanks to Uber Air and Bell Helicopters, I'm picking on Uber a lot today. And Bell Helicopters, we will have autonomous airborne vehicles carrying passengers next year. Super exciting. But the idea of how we pull all that data together, and we talked a little bit about this in the transportation group, how we think about the ethical implications of that, how we start to think about working across the digital divide, getting people familiar in areas where they wouldn't necessarily think about getting in one of these vehicles, how do we get them comfortable with it, is all part of what we're doing as an ecosystem and gathering all these people to work on data science together. One of the ways in which we're doing that in a very super geeky way is with the mobility data specification that we have launched on GitHub. We've just launched, in addition, the Open Mobility Foundation. So we put this specification out on data sharing with micromobility, which is scooters, bikes, and then Uber and Lyft as well. And as part of that, we just have these data sharing agreements. We need to know like anonymized data, like where you're dropping these things off and where you're picking them up, so we can build public spaces to make it easier for people and safer. And then 43 other cities have adopted this. We've now opened it up as a nonprofit. And this is really a precursor to how we'll be doing data sharing around autonomous vehicles. And then just to kind of like spin a little bit from LA very quickly, I know I'm out of time, is it's not just about like what we can do with high tech, but so I also have a nonprofit in Africa, and we recently got a micro grant and completed a project called Clean Streets based on the same idea we have in LA around a My LA 311 app, which is letting people go out and crowdsource where streets need to get picked up and where trash needs to get picked up. But we funded activities in Kampala, Uganda, Accra, Ghana, and Bo, Sierra Leone. And mapping was the key, as it is on many, many of these projects. Underneath all of it, essentially, almost all of our data is geospatial data at the heart. And it's all got a location because we're a city, like it's a place. And so the Clean Streets project was really looking at how to get trash picked up faster. And so we had super creative solutions. In Ghana, they created a mobile app that helped people be able to identify and report. In Bo, they worked with municipal government to get trash pickup faster. And the best, my personal favorite. In Kampala, Jeffrey Cataraga enlisted the boda boda drivers. So these are the little motorcycles you jump on the back of as like taxis. Super dangerous, super fun. The boda boda drivers, they're traveling all over the city. And so we just asked them to turn their GIS, the GPS on and snap pictures as they went through the city of all of the trash heaps. And then we aggregated that and then reported that to the municipality, which I thought was super creative. So really, as we pull this all together, we think about the future training of data scientists in 3 communities. First, our bigger community, which is around things like citizen science. And if you haven't seen the Federal Citizen Science Toolkit, it's available online, has been for a few years. Leah Shanley led a great group of us working on that. We work with our local Code for America Brigade, and we do a lot of these data literacy programs through our LA Public Libraries. And we also have a volunteer corps called Data Angels, because we're the city of angels. It's a great name, you know. So our Data Angels program, in college, we say once you're on the track of something in STEM or public policy or health, like we don't care where you're coming from, but we want to make you a data savvy person. And so we have the Data Science Federation. We, for every graduating senior of LA Unified School District, and we have 650,000 kids, we give 2 free years of community college in Los Angeles. And so we can launch people into a free community college for 2 years to get them onto a UC or other system. And then our Cycle LA is a program where we give away computers and Wi-Fi to low-income families and kids. So this year we gave away 6,000 computers to College Promise students. And then we have the Tech Talent Pipeline, which is a partnership with our local Chamber of Commerce that takes kids from low-income neighborhoods and non-traditional backgrounds, and we fund them each summer to come to the city or Google or Snapchat or Blizzard games, because games are great. And we help them get into data science and then offer them jobs. And then we have all these great programs for K through 12, including Cyber Patriots, which is a national program available in all of your cities in the US that helps kids as young as 3rd grade start learning cybersecurity skills. All of this helps us kind of organize ourselves. We are a city that has adopted the SDGs, which I proudly wear, gender equity being my favorite SDG. And we have adopted the SDGs as a city, driving towards successful decrease in poverty, hunger, and increase in equity and climate action. And that's what we're doing in LA.
I think the plan is to save the questions for the panel. I missed the introduction, but I don't know how amazing, you know this woman is. She's, I was just like, she's got the NASA Exceptional Award twice. And my favorite, she's a top 50 woman in tech, and she's with us today. So thank you. And what I'm learning is the secret to impact is this energy, even at the end of the second day. So let me challenge Patrick to see if he can top that. This is a very weird event, you guys. Usually, you know, the energy goes down. I'm seeing the total opposite. It's like the afternoon has more energy. So while Patrick is setting up, so Patrick comes to us from ESA, the European Space Agency, and he's in the Earth Observation Directorate. And he does development and support of digital platform technologies, which, as you'll hear, involve analytics, innovation, and partnership with industry on things like data analytics, data science, and AI. Just in time.
Is this good?
Should be good.
Should be good. Do I have
Yes.
to press it?
No, it should be good.
Let's display port interoperability first.
That's good.
Otherwise, it's standard HDMI. will also work.
Take your time also.
Okay, sounds good. Great. Okay, thank you. Okay, good afternoon. I don't think I can keep up with the energy level of Jean. Also because jet lag is kicking in, and you know, it's almost the last talk of the day, so I hope I can hold up. Okay, so I come from ESA, from the Earth Observation Directorate, and I want to talk about three things here. One is kind of the ESA perspective on the data deluge or the big data for Earth observation and the requirements that result out of that for data storage, accessibility, and services. And then bring an example of a major policy piece that is strongly affected and taking advantage of this new data-rich environment. So, you know, at ESA, there's three big programmatic lines. There's the science mission, the Earth Explorers. Then there's the Copernicus mission that you all are familiar with. And then we have the meteorological missions that are operated by EUMETSAT, right? And that's currently 25 satellites under development, 15 in operation, 12 in preparation. And if you look at the, you know, this exponential curve of the ESA data archives, you know, it's we're kind of getting to several 10, 15 petabytes per year now. And if you look at the distribution here across these missions, you see that, you know, the Sentinels are obviously the big game changer here in terms of data volume. Whereas, you know, Earth Explorers are great missions, but the data is a little bit less accessible and requires a little bit more expert knowledge maybe in addition to that. So the Copernicus Sentinels, as you know, this is co-led by the European Commission and ESA. So ESA builds and operates the satellites, and the European Commission owns this. So, you know, the Sentinel-1 is a you know, all-weather capability synthetic aperture radar with two platforms, Sentinel-1A and B, in orbit and operational. Sentinel-2, multispectral, building on the Landsat heritage with you know, 10 and 20 meter bands and nine main spectral channels. Also, again here, Sentinel-2AB in orbit and operational. Sentinel-3, more like the MODIS instrument, so global observation capability with daily acquisitions, global acquisitions. Sentinel-5P is the precursor to Sentinel-5, but with the TROPOMI instrument that provides some really interesting data on atmospheric composition, trace gases, and so forth. And you see here already that, you know, the C and D components of these missions are planned, financed, and almost ready built and will be launched. You know, this covers the time period until 2030 roughly. But the Copernicus program is also going into the next generation, and Copernicus 4 is being discussed. These are the 6 Copernicus high priority candidate missions. There's a hyperspectral mission there. There's a high temporal, high spatial resolution, land surface temperature mission, atmospheric missions, the L-band radar mission, and so forth. So this is really the game changer program, as you all know. And but at the same time, you know, ESA is realizing that there's more and more, like other space agencies also are realizing that there's more players, new players, in terms of new space companies. And all of these constellations that were to be expected during the next years, you know, I mean, Planet or Terabella, or what is this new, you know, these great new synthetic aperture microsat constellations, really amazing things. So, you know, the data situation will be further increased. You know, it's a, you know, the great thing about Sentinel, so of course, there's freely available, open access, freely available global acquisition capabilities. So that's, you know, let's see to what extent these data sets will be available. But of course, you know, Sentinel's also precisely calibrated geometrically and radiometrically, and it's kind of, you know, always considered a gold standard against the slightly less well calibrated measurements from these microsats and small sats. And then the last days we heard a lot about the IoT, and that we kind of expect a big impact, but we're not really seeing that yet. And also for Earth observation, you know, this is kind of the vision for the next years. You know, there will be a big impact when we can actually take advantage of IoT, and then we're going to have like several levels of data acquisition here with the satellites, and then the HAPS, the high altitude pseudo satellites, drones, and the IoT sensors on the ground. And all of this is supposed to be connected and interconnected. And, you know, if we really have this, this will be a big change. So the question is a little bit, you know, with all this data, you know, how do we handle, store, process these things? And I think this layer diagram that we work with here that depicts the Earth observation platform ecosystem is similar to what we saw earlier from our colleague from Japan here. A lot of common elements, I would say. So, you know, I mean, obviously the old model of downloading files and running processing on your local workstation is kind of obsolete. So we have, you know, distributed storage environments co-located with distributed compute environments. And then on top of that, we have basically this layer of platform and exploitation tier layer with platform services and, you know, data cubes and analytic environments to take advantage of all of this data. Really essential with all these, with this high data volume is basically data access. And one of the important developments here are, of course, data cubes. And I think, you know, it depends on the definition of what constitutes a data cube. It varies by person to person and application to application. But for me, coming from the kind of optical land domain, for me, the main point here was always that we can, you know, align the data in a way so that we can directly exploit the temporal dimension. This is a figure here from the Australian colleagues, right? And once you have it in this shape, then you have this simple data access that's basically one line of code in Google Earth Engine, right? Where you just define a collection, a time frame, and a spatial, you know, rectangle to access the data. And you don't have to worry about anything like projection, reprojection, or file overlaps, or stuff like that. So you know, this is a big boost in productivity if you have the data at this level, and you can just ingest it and access the whole archive without having to worry about pre-processing data management, which often took up to 70 or 80% of the Earth observation scientists' time. So, but the main improvement with the Sentinels is, and I think everyone in the land community would agree to that, is that the more data we have temporally, the better the information retrievals and the application results in the end, you know. And with the operational Sentinel-1 and Sentinel-2, we have a global revisit of 5 days for both missions. And we have, you know, due to the orbital alignment of the tracks, you know, we have many areas, we have revisits every 2 or 3 days. And that is a big, big game changer. And, you know, with more temporal data, one of the application fields that has benefited probably the most is agriculture, because that's, of course, a temporally dynamic phenomenon for which you need a lot of, you know, observations through the growing season. And this was in part also part of the motivation for the Copernicus program to support European policies. And one of the major European policy element that has really benefited from the Sentinel data is the Common Agricultural Policy. I don't know how much you know about this, but it's, you know, the single biggest fiscal budget item in Europe. It's 43% of the total budget of the European Union. And it's mainly, you know, it mainly pays subsidies to the farmers to make agriculture still economically viable for the farmers. But it also has elements for, you know, to enforce environmental policies and, you know, to lead to more sustainable agriculture. So, you know, there's still a lot of problems about the cap, but it has come a long way. And so traditionally, the Common Agricultural Policy compliance checks, so to see if the farmers are actually doing for what they are receiving subsidies, this is traditionally done through interpretation of a very high resolution imagery for a 5% sample per country. And then for a smaller percentage of those parcels, there's on-the-spot check in addition to the VHR imagery interpretation to determine the compliance with the subsidies that were received. And this is really complicated and inefficient and you know, very problematic kind of way of doing things. And yes, since 2018, we have a regulation in place that basically pushes this system now into permanent and continuous, so throughout the growing season and for all parcels in Europe that receive subsidies, a fully automated monitoring based on Sentinel time series. and analytic tools that come basically from the data science community. This is a big step, and there's a couple of interesting aspects to this, because of course this is kind of moving into the question of legal liability of remote sensing based evidence for compliance. And here's just a simple example of 3 cereal parcels, or parcels that grow cereal here in 2018. And this is kind of the density that you get from Sentinel-2. We see the harvest in all 3 parcels. But then there's another thing. So these farmers can grow catch crops, right? But catch crops have to be destroyed mechanically according to the Common Agricultural Policy requirements after a period of 2 or 3 weeks. And so this on the lower right, that parcel is obviously not compliant. And that's just a simple example to show you that with the temporal detail that we have now, we can see these things in very good detail. And then I think there was in the earlier talk, there was something on optical and SAR fusion. And of course, here already you saw that there's, a lot of clouds. So, optical data is limited to a certain extent. And with Sentinel-1, we have this all weather imaging capability throughout the year, day and night, descending, ascending orbits. So this is amazing. And here, I think this is really one of the areas where I think machine learning can, new machine learning methods can make a big difference. So I showed this example here from a company in Belgium called Vito. And what they did here is they basically have a model that derives FA-PAR, so the fraction of absorbed photosynthetically active radiation, based on observations from Sentinel-2, which you see in the top graph. And at the bottom, you see the coinciding Sentinel-1 observations. Look at that density of observations and look at the sparseness of observations in the Sentinel-2 data. But what they do is they have a convolutional neural network that takes the Sentinel-1 data and makes predictions for the FA-PAR value for Sentinel-2. And you basically get this nice uncertainty estimate around your measurement, and the more, it's then corrected through time with incoming Sentinel-2 observations. But, this is, I think, really, we haven't seen a lot of good data fusion approaches, but, these are really exciting new applications for bringing together optical and SAR data, and then basically further increasing the usefulness of the Sentinel data. So that's all I had. So, in summary, more Earth observation data, the better, and more temporal data in principle. We get better applications, better information retrievals. And algorithms are increasingly moving to the data. That's nothing new, but, in 2019, we're almost there. And pixel-based data access to analysis-ready data is what the users want and need, and that increases productivity greatly. And finally, this example with the Common Agricultural Policy shows how, Earth observation data and methods from the broader data science domain can be used to monitor and enforce a major EU policy. I forgot to say that there's also now a new regulation in place that will look at do an environmental impact assessment of the CAP. So look at whole Europe and see to what extent the greening aspects of the Common Agricultural Policy are actually leading to improvements in the environment in Europe. So that's really quite exciting, I think. That's all I have. Thanks.
I think he did well. What did you think? Matching Gene, yes. Plus, I loved how many times he repeated how it helps us improve productivity. So going back to the basics. So my pleasure, as Stephanie is hooking up her laptop, to introduce Stephanie, our last speaker of the day. Woohoo!
Woohoo.
So
Last but not least.
Definitely not least. So Stephanie is the Deputy Director of the Social and Decision Analytics Division at University of Virginia, the Biocomplexity Institute. And I love this, she creates and implements new programs to build data science capacity in cities and counties of all sizes. And what she highlights in her bio, like the one word she highlights is, You know, she focuses on innovation and tools for using all, and that's what she has, all data to address social science policy questions. So all yours.
Thank you. So this is really exciting to be here these last 2 days. I thank George and Nadine for inviting us to be here. We work with local communities to build their data science capacity. And while we do that, we're building our data science capacity as well. We start by working with them and asking them what their issues and questions are. And really, we start these local conversations with saying, what keeps you up at night? What questions can't you answer that you would like to right now? So as Nadine introduced us, we are part of the Biocomplexity Institute, which is part of the University of Virginia. Scientists in our institute model they scale from bench biology at the theoretical level, and we scale to societies and populations driving towards evidence-based policy. My social and decision analytics division is obviously on the societies and populations side of this mission. Our work brings together a variety of local, state, and federal data, administrative data, opportunity data, and procedural data. And we use, as I think Jean had a great slide that was up that looked at all the different methods that we use, but we primarily focus on statistical analysis, combining that with geospatial and machine learning. So I'm going to present a few examples from our early work, so they might look a bit naive, but I want to set the stage for how we got to where we are today and how we got hooked on working with local governments. So when we first started our lab in 2013, we thought we would be working in the mega city space and involved in a lot of working with the sensor data and the Internet of Things. But when we walked out our front door in Arlington County, Virginia, and we began talking to the fire chief and the chief information officer and the people that collect our tax data, we began to get very excited. And so the fire chief came to us and he said, I have all this 911 data and it all sits in silos. And could you link these data end to end in order to recreate incidents? And if you could do that, I would better understand my day-to-day operations. So he didn't really want predictive or dashboards or things. He just really wanted to understand his data. So that was actually the easy part. And this was one of the first things that we did. We had a group of summer students and they put together this map. It's 3 years of data and it's looking at 911 incidents by time of day and day of week. And we were so fascinated by this the first summer, and you sit there and you can see that Monday is different than Tuesday, and Tuesday is different than the weekends, and the evenings and during the night are different than the early mornings. And we got very excited by this because also the fire chief had said, I understand who my resident population is in Arlington, but I don't understand the hundreds of thousands of people that come to work in Arlington and flow through Arlington. And when we were looking at this, we were struck that not only were you mapping 911 incidents, you were mapping flows and densities of people that come through Arlington by hour of day. And the fire chief also got very excited by this. So moving on, we began to work with more and more agencies within Arlington County. And in fact, at one point we had a data discovery workshop in which we brought together 90 of the leaders across Arlington County's government just to begin to teach them about data science and the possibilities of what it could bring to them. And one of the big things that we were doing was trying to break down the silos across these agencies. So let me just give one example of how that worked. The parks, well, uniformly, I'll have to say that what they were most interested in is not who they were delivering the services to, but who they were missing, who qualified for their services but either didn't know about them or didn't engage in them. They care passionately about that. And so the Parks and Recreation were the first in the queue to come and say, we offer these subsidies and we want to understand why certain families that would be eligible for these subsidies are not participating in our program. And so if you look at the top map on the right-hand side, that's all the families who are participating in just the subsidies to participate in Parks and Recreation programs. And Arlington sort of has a divide. The north part is considered, quote, rich, and the south part less so. But you can see that these subsidies are sort of spread. It doesn't really tell you much, right? So we decided that what we needed to do was to compute two different kinds of composite indexes, both focused on vulnerability. And actually that's portrayed in both the maps. And we combined some socioeconomic variables, for example, percent of families whose rent burden is greater than 50% of their income, or they're participating in social benefit programs. And we mapped that across neighborhoods in Arlington. And so the darker the color, the more vulnerable the neighborhoods. So Arlington sort of knew that, but this helped confirm that. And then we created a second vulnerability indexes by the schools. And we used the school level data such as percent of children participating in English proficiency classes, or those who were eligible for free or reduced lunch programs. And so the size of the circle represents how vulnerable the students are there. And they're somewhat overlaid and they align with our economic vulnerability indexes, no surprises there. But then what happened was that not only did the Parks and Recreation understand where they could target outreach or improve their programs, the Human Services Department and the schools began to get involved too, and not just target outreach, but began to reshape their policies so that they could reach out to these children in need and ensure that they also were participating in the programs across Arlington. So this was the second story where we really got hooked, and we got convinced that these data, these administrative data at the local level, when you combine them with other sources, are very, very powerful. So then we move on to Fairfax County, and they go, well, this is all really interesting and we like the work that you're doing, but we don't really find it actionable to look at data at the census tract level. We are really much more interested in looking at data by high school pyramid boundaries, your high school, your 2 middle schools, and your elementary schools, looking at those districts, or looking at our political supervisor districts. Those are the areas of geography that are of interest to us. Those are the areas of geography that are actionable to us. We can take action through our school system and through our political districts. So we thought about that and we said, well, right now, the American Community Survey and some of the other federal sources of data, they're not aligned to provide data. You're sort of stuck with either zip code or census tract or census block. And so that's when we took our synthetic technology that we had been developing for other reasons, and we realized that it applied here. And so what we did was you take the public summaries of these data and you can match them with the microdata, and you impute synthetic people, the 1.2 million people that live in Fairfax County, and then you can place them in their households. And now you can reweight it and you control for a handful of variables. This is very similar to sampling. In our case, we were using age, income, race, and poverty, so that your totals sum back up to your published totals. So we didn't have the same problem, which I would have been more interested to delve into with the time series. But this is a pretty straightforward method that allows us to now draw new geographic boundaries that allow you to look at data. So in these two maps, for example, it's just one variable, the percent poverty. In the top map, you can see the percent poverty by the high school pyramid boundaries, the 24 of them, and in the bottom by the 9 supervisor districts. So that's just using one variable. We then went on to create what we call CommunityScapes. And so this is, again, reflective of the fact that communities are composed of very diverse neighborhoods and not just census tracts. They help us conceptualize where we live, learn, work, and play, and they lay a foundation for a quantitative understanding of the kinds of the social determinants of health that policymakers are interested in. So in this case, Fairfax, one of the issues that keeps them up at night is the increasing obesity rate, especially among their youth. And so they asked us to look at and create a composite index that would help them identify where risk for obesity is high in Fairfax County. And again, that way they could target policies to these specific areas. And so again, we created a composite index that looked at not just socioeconomic factors, but also their access to healthy food, their access to physical activity. And so this looks somewhat different than the vulnerability indexes, although some of the areas do overlap, which is not surprising as well. And then in part of the overall analysis, we were also able to capture the analysis of youth from a Fairfax County youth survey that's administered every year as well. So bringing this all together, we have worked with many different kinds of sponsors, from industry to federal statistical agencies to DoD and the US Army, as well as the local government examples. And out of working these really applied problems, we call this a research pull, we have created a data science framework. And what's a little bit different than what was in the conceptual paper that you provided to us ahead of time, or what you see in many data science frameworks, is that most of them start at the third step, at data acquisition or data ingestion and governance. And so what we think is novel about it, and we actually had great discussions yesterday about this, is what's key is working with your sponsors to identify what that problem is. And so Fairfax came to us and they said, we're concerned about obesity, but then what is it that we're trying to answer about obesity? We're trying to understand their access to healthy food, their access to physical activity. And so you begin to sharpen what those questions are. You do that by both, of course, looking at the literature, but also talking to your sponsors and talking to experts as well. And then what we think is really novel is our data discovery. You don't just start with the data that you know, you don't just start with the data that's readily accessible. And here's where having our young people work with us, because they are masters of data discovery and identifying unique sources of data that come to bear on these problems. And then the process becomes much more like what other data science frameworks are, where the data wrangling, you're profiling the data to assess your data quality, and you're preparing and linking and exploring. And all of this is iterative. And so we think it's rigorous, it's flexible, but it's also iterative in the work that we're doing. That data wrangling takes about 80% of your time, and we're hoping with what we're doing to create the science of all data is that we'll move that needle down. It would leave more time for statistical modeling and analyses as well. So finally, the last piece is the ethics review. And we've heard a lot about this. We heard Andy Brooks talk about how that's sort of the last stage. What we think is that the ethics review has to be built into every stage of your research. And so we have set up a very generic checklist that provides a guide for this discussion. And I will have to say, I'm going to talk about our data science for the public good program. When we introduced the ethical dimensions this summer, a lot of the students really didn't get it. They get data discovery and they get learning how to code and do this, but the ethics, they're like, if all the data are public, I don't understand the ethical dimensions. So we had to have some long, deep conversations about this throughout the project lifecycle. So getting to training our next generation of data scientists. Here's our data science for the public good group from last summer. We do a national search for undergraduate and graduate students. Here's some examples of the applied problems that they work. All have a sponsor. They always start with the sponsor can give us data, but that's not a requirement, unlike other programs that they do. We emphasize the first thing they learn is our data science framework. Many of them come to us and they don't know how to code, and at the end of 10 weeks, they have all learned to code and are proficient in that, as well as the broader data science world. So they work through their problems using multiple domains, and we're very excited about this program that we established in 2014. So this is an example of some of our sponsors. You can see a lot of them are local governments or the federal statistical system. One of the things that we're most proud of is that we, at the beginning of this program, thought that if just 10% of them went into civic activities or civic jobs, that would be a success. But in fact, from 2014 through 2018, over 25% are now working in either for NGOs or for primarily local governments, but some for the federal government as well. About 20% are in graduate school and the rest are in the private sector, but we consider that a huge success in terms of creating a next generation of data scientists for the public good. So we are beginning to ignite a national movement. We received a USDA grant to bring the Data Science for the Public Good program to Oregon, Iowa, and more broadly across Virginia. And we're doing this through the Cooperative Extension Service and through a process that we call community learning through data-driven discovery. So we were asked to make a list of actions. Through our discussions over the last 2 days and through things that I care passionately about, have suggesting a list of actions that data literacy is as important as becoming a full-fledged data scientist. I think that some of the actions that we need to address are data sharing agreements. They often get in the way and hold up our work. There's ways to overcome that are not terribly hard. Training that we've been talking about through both of our talks. And then, of course, the ethical dimensions of data science and geospatial research. And finally, something that we haven't talked about too much is privacy. We are an advocate that you don't mask this data, but instead you punish misuse, and you find ways through either data enclaves or research agreements that allow researchers, legitimate researchers, to have access to these data. So we'll end there.
All right. You need a microphone over here. We need to pass something.
Share.
So I don't know who voted on the questions, but thank you. So I have a list handy, but I'd like to open the floor first. If you have any questions for the panelists, right here, Ajay, please. Thank you, Ed.
Thank you. Thank you. This question is genius for you. You mentioned that a number of projects where the data was sourced by just people, just citizens on the ground. Do you have a sense for how accurate that data set is, how high quality those data sets turn out to be? Because I think they turn out to be really accurate.
I totally agree with you. Citizen science can be super accurate. So when I was at the White House before on the data.gov team, we created with a bunch of other folks at the federal government the Citizen Science Toolkit. And so I just referenced that as a way of trying to bridge this gap between national statistics offices and science organizations who said citizen science is interesting but not really accurate. And so we said, look, if you follow these methods for collecting the data, using metadata, tagging it in certain ways, then actually a lot of the scientific organizations could use it. In California, for example, we have a huge issue right now with decimation of our butterfly populations, which is really important, actually. And so citizen scientists are really important for that. Even in our air quality work with NASA, so I have asthma, and I have a GPS device on my inhaler. We're giving those away to school kids in our most asthma problematic populations. And so they use their inhaler when they have trouble breathing. We anonymize that map and share that data so that as a city, we can go and send investigators to see where those issues are that are causing population problems around breathing. And then individually, that information is useful to the kids because just knowing where you get irritants in the atmosphere or where there's particulate matter for you or allergy issues, you can decrease your daily asthma attacks by 85%. So, so we strongly believe in citizen science. Sometimes it's more for the getting kids engaged and understanding about data and data collection and the power that they have to contribute. And sometimes it's because we actually need them to do the work.
I'll just add one comment to that, is that I'm on a National Academy Committee that's looking at prizes and crowdsourcing. And one of the biggest challenges is just getting government agencies to embrace doing the crowdsourcing. So I think that's a reverse challenge in a sense.
Add something too. So for the Earth observation community, there's also great hope on citizen science. The problem is the quality assurance part. You don't, and there are some things to work on that. Like the gamification aspect or crowdsourcing, or you can do a reevaluation of citizen observations. You can look at how a certain citizen voted for a certain thing also. And the other problem that we have with it is that the labels that citizen science provides are often kind of qualitative rather than quantitative. But then, things like you describe, or small handheld, small sensors or so that actually give you a quantitative reading are really valuable, right? For air quality, there's something, or for even for, forestry attribution also. So these things are really interesting.
All right, I'll ask the top question. Again, I don't know who you are, who voted, but good job. It's a question about open data. It appears to be a crucial element in the data science workflow. So what can we do? Action, again, to further increase and ensure availability of open data.
happy to start with that. One of our projects with Arlington was to evaluate their open data and make recommendations to them. Okay, is this not on?
Just close.
Oh, okay, thank you. So I think that one is the question of availability of open data, which I think increasingly has soared in terms of quality and quantity. But the other is making it more standardized if possible. It comes in all different formats. And I mean, it's not, these are challenges that can be overcome, but it also needs to come with more metadata as well. It seems to be, you know, compared to 5-6 years ago, it's much better than it was. It still has a way to go in terms of being standardized. Another place for standards, maybe.
I can maybe add to that only the Earth observation perspective. And again, you know, we have the big open archives of Earth observation data, free, calibrated, readily available. But what's lacking is the, you know, availability of in situ data, reference data, and training data. And here, you know, I was mentioning that earlier to a few colleagues here already, especially the land applications community is very unorganized, you know, because it's so heterogeneous. So, you know, research groups have their field data on some weird storage media, old, you know, not according to, you know, common protocols for the collection of the data. And also, you know, in terms of metadata and actual data formats too. So, you know, it would be great if we could motivate these research groups to reprocess their field data, their reference data, and bring it into a standardized format. And we actually have a pilot activity on this now to do a community review to look at, you know, best practices and data set specifications for reference data and training data. And then basically to create incentives for people to reprocess their field data and make it available in a curated and long-lasting way. So basically, you know, in the era of open data archives for Earth observation, at least, you know, it's the reference data and training data, the CalVal data, that's really lacking. And that's also kind of hindering the major breakthrough of new machine learning technologies, I would say.
And I'll just, those are great answers. So I'll just add to it that there's this whole aspect of getting people to publish the data in the first place. And there's issues around both, you know, sort of expertise and liability. So like, we should just be really clear that in the US, it's not true, but it is true in Europe, that if you publish as a government person, data that's flawed, and we know that all data is flawed or incomplete to some extent, let's just be honest, that if something happens, if an autonomous vehicle follows your road data, but it has an accident and injures somebody, you are potentially liable individually. The US laws are slightly different. And so when we started building data.gov, I had to convince the folks at 175 federal agencies that it was okay to publish messy data. It was okay if your data was incomplete. It was okay, you know, if you were publishing the data the best way you could today, you just also had to be open to getting feedback on how to improve your data. And you had to be really honest about where your data was incomplete. And nobody was going to, well, we weren't going to hold you liable. People might judge you. And I think that that issue of change management, behavioral science, is really important in how we open up data and keep it open. And then we can't also ignore the political issues around keeping data that may be inconvenient for one administration or another, keeping that data open from, you know, over time, because people are running businesses and they are running analyses, and data journalists are linking to this data all the time. And they need to have real-time, accurate data that is, you know, standardized to the extent possible, but accessible over time.
Any questions? Yeah, Hamad?
I have more of a comment than a question on the open data and sharing data out of research particularly. In many cases, I mean, researchers receive particularly federal grant money and they are supposed to publish data openly, right? But the challenge that you briefly mentioned is the incentive and resources that they don't have. So they do the research, everything is ready, results are published in a paper. At the end, you see in a statement, email me to get the data, right? The reason is that the PI and the student or postdoc don't have the incentives to put it in a public repo or document it, or don't have the technical resources. Usually they are more of a scientist than an engineer. I think one thing that would be helpful is policies and resources in those grants to help grantees to share their data openly, beyond just the policy, but on the implementation side.
I think that's a good point, you know, and I think we're seeing more and more that final results and products from scientific papers are actually made available already. You know, there's data sharing environments where people host their scientific result data set and link to it. And, you know, I think what we're now also beginning to see is that things on GitHub also are linked into scientific journal papers. And also, you know, with Jupyter Labs, also you can actually, you know, share methodology and data at the same time. So that's like, I know some people refer to that as the gold standard of scientific sharing and reproducibility. You know, that's. But I like the point about the, you know, creating an incentive already in the on the project formulation that you say like this has to be shared or so.
So it's taken us a while to do this, but for the last 2 years, we're finally at a size and structure that allows us to make our data available and our code through GitHub. And so we're beginning to do that as well more and more, but it actually took more work than we expected it to. And as you say, that knowledge and sort of having that extra resources to be able to do it. So it's not trivial, especially if you're just, you know, a research team of 2 or 3.
So I'm curious.
1 minute, 1 minute.
Wake me up.
Now I forgot what I was going to say. So the statement you made about the Patrick, the need for ground truth data. I'm curious a little bit more on your thoughts on that and opportunities to address it and efforts like GeoBond and kind of standards that help the community writ large generate data in a way that's usable in those applications.
Yeah, you know, earlier in the session where you spoke and the colleague from the Climate Corporation, I was going to ask that question. I wanted him to specify, you know, he said they have these something trillion data measurements, right? And he said, and we're working towards defining the standards and everything. I wanted to hear his opinion, but he left you. I didn't get to. And I was also going to ask you, because you said that you have worked on how to, you know, protocols or, you know, best practices also for how the data should be curated and generated. So, you know, I think, you know, as I said, it's very heterogeneous depending on the community, how that's done. So I think like, you know, we're doing this community review to see how different initiatives are doing that. Radiant Earth is, of course, already going along that line. And I think, you know, overall, everywhere we're hearing the same thing, that people are realizing that this is kind of lacking. And I think there's a couple of efforts underway to do that. I mean, you know, it really depends on the application example. If you look at land cover, there's very elaborate protocols. And, you know, in Europe, we have the Lucas land cover survey. It's very, very detailed, established methodology and, you know, metadata agreements and everything. But things like, you know, yield and biomass and these kind of things, they're much more interesting. And, you know, if you look at, I always like to bring up the example of, you know, mapping biomass in the South American Amazon. There's been ground campaigns since the late 60s also, right? Measuring, you know, doing forestry inventories and doing field forest plots and stuff, right? Imagine you can bring all of that data together, right? That would be such a rich data set. So it really depends on the community and the application that you look at, I think.
And I think there is, I mean, I've noticed in my own work in the past couple of years that there is a push for that. There's in the biodiversity world, there's Darwin Core and other, you know, we've maintained our own standards within our network for a long time, but now we're thinking more globally about how can you apply these in these new kind of international frameworks to maximize the reach. So it's an exciting time.
Yeah, and also, you know, thinking ahead a little bit in the future, like, you know, you're going to have maybe, you know, the aspect of training data interoperability would also be interesting, you know, because you might have one environment with GPUs, one environment with distributed storage and compute, and then environments that host reference data, and you might want to query different reference data sets for the same type of measurement, federated access to different reference data sets would be super cool. So, but, you know, so that aspects of interoperability would be interesting to see if OGC would, you know, want to pick that up at some point, I think. Yeah.
Cool. 2 more questions. Yes, Antonio. He's earning his steps. Thank you, George. Doesn't count.
So I've seen that two of the main problems about access to data is first is availability to data that is actionable, and the other is making sure that the data is good quality. Do you see that there is a role for entities that behave as data authorities in the future, that let's say that centralized sources of data validate them, they ensure that the data and the metadata is good quality, follows the standards, and they simplifies also the data sharing agreements? Or do you think this is not a viable model and that the data will still remain in a big lake of data where you will just have to look for it by yourself and figuring out yourself if the data is good or not?
Well, I think we've, in several of the groups, we've talked about this issue around data sharing brokerages or Tinda for data sharing agreements or something, is that we need to start making the data that is not fully open or is open under certain conditions accessible. So I know we all have like Creative Commons and different licensing that we can apply, but if we don't sort of proactively figure out someone has a need and someone has some data, how to put that together. So we have, sort of aggregation sites like data.gov and the UK sites, and we have all these national data portals and others around specific areas. But I think there really is this idea, this potential need for that, sort of provenance checking. But it's sometimes difficult to figure out which international entity could do that. At a national level, like I did a lot of work for the World Bank in Central Africa. At a national level, there's things that you can do like in a country level. And certainly I've seen that some of that happen in the US, but internationally, it's probably a little more difficult.
I'd like to make one comment about, well, a couple of comments, but in terms of data quality, I like to say that the quality of the data are useful depending on your purpose. And sometimes the data may not be the highest quality, but it may still provide important insights into what you're trying to answer or address. And so we talk about it's more understanding the strengths and weaknesses of your data. So you look at Twitter data, it's young men or no, I mean, that's now expanded, unfortunately, to older men as well. But anyway, but we know sort of the demographics of Twitter data to some extent, and that's also evolved over time. So I think that sometimes I want to be careful that we don't just throw data out because we think they're poor quality. We want to maintain those. With respect to your sort of an organization, I mean, we have some of those in the United States. Some are very bureaucratic and hard to access, and others are less so. So Pittsburgh has a model having data warehouses. Seems to be pretty dynamic, and researchers have access to this data without having to go through the gathering and data cleaning, and those data are there. But you could see that quickly. Our research data centers that the federal statistical agencies run are valuable, but it takes you over a year or longer to gain access to those data. And that just can't be. When I was at NIST, we had a valuable source of innovation data that we made available through the NORC Data Enclave that was actually created for that. And since then, many other federal agencies are putting their data in there because the turnaround is less than a week or a month. It's very short compared to the research data centers. So we need to figure out a model that's dynamic and flexible and allows researchers quick access to these data so they can get in and not wait the whole year or 2 years to access it. So I don't know if there's a perfect model yet, but I think it is something to strive for so that we're not all reinventing the wheel of finding these data sets and describing them and creating the metadata for them. So no easy answers, but.
Thank you. So I'm going to close with one question, mostly to help our rapporteur, Adam. Actually, it's two questions for each panelist. So we'll go maybe Patrick, Jean, and Stephanie. So the first one is, what would be your top recommended action? And the second question would be, what do you think OGC can help with as a community? Adam, get ready.
Well, I think honestly, you probably already heard that between the lines, that I think we should really think about having this reference data, ground truth data, Calval data, training data in the end, to think about that direction to provide, data set specifications, protocols, and then also, environments that are dedicated for working with training data and curating training data on the long term. And, I'm not so involved in all the standardization activities, but I think it could be good to think about that too. And as I said before, also the interoperability of these reference data repositories or training data repositories is something that could be really, really valuable. So I would, that would be my 2 points to put on the list.
One of the things I think that would be helpful, schema.org and others have helped to create searchable, like file type data is now something that you can search for in Google. And so expanding that standard to include the data sharing agreement aspect of it, like right, now you can look for images that have certain copyright or open use standards. Having that applied to the data that you find on Google would be really useful and a relatively straightforward thing to do. And it would take a long time to eventually get it to be adopted, but I think that would be important. And then I think the other thing is, we've talked about this, but I want to lift it up again, is the digital code of ethics. Is, if we could figure out sort of those things about inherent bias and transparency and, unintended consequences, and figure out a set of values that maybe the community writ large could, step up to, then organizations could potentially sign up and say, I also, like the Paris Climate Accord. As an American, I can say that. That we agree to adhere to these because it's of value to the community.
So something that's been swirling in my head the last 2 days, because I've been really impressed by how many people are here from the private sector, is, well, what about private sector data? And we do know some companies provide that. Some provide it if you're a researcher, and maybe then the data on quality are unknown, but that's part of what you as a researcher are doing and hopefully contributing back to the community. But there's also data sources like CoreLogic or Burning Glass that charge a lot of money to get these data. The data quality are really poor, and yet they're really valuable data. And so the CoreLogic data provide you property tax data and characteristics of housing units, and in some localities you can even get the rental units. But the data are, why every researcher would have to reinvent the wheel on that is unknown. And not only do you have to reinvent the wheel, you're spending lots of money to access that data. Again, I don't know what the solution to this is, but I do think that the private sector needs to step up and make data accessibility and data quality an important issue, and be able to be part of this research community in terms of providing good, high quality data for very important issues. So that's one of the areas, and I was so passionate about that. I now can't remember the second area. I think it's related to the data ethics, though. And I do think that the data ethics is just absolutely critical to what we're doing, and you've already said it very eloquently, so thank you.
Cool. Well, you're happy? Adam is happy. George, you're happy? All right. Thank you so much. Thank you, the panelists, for the energy at the end of the day.
Okay, so we've learned a whole lot. That means there'll be a test. Actually, the lucky thing is we already had people preparing the summary throughout the day. So let's spend a couple of minutes reviewing what we heard for you all to take away with you. And one of those was how to connect a computer. Lordy, lordy. There we go. Yeah. Okay, session one, who remembers what happened? This is what happened. Mark, I don't know if he's still around. I'm not going to review everybody that's still around. Mark gave us a really great fundamentals presentation. Nils gave us an inspiring kind of look at the history of video. We had an excellent panel, Kathleen, Anand, Mark, Giant. And so each of these summaries will be, I think, if they all use the template, in three parts. One is what works, second is open questions, and third is next steps. So what works? Lots of things are going on that are valuable to data science, massive quantities of data, parallel analysis, video analytics, the whole ability now to do space and time, look at changes in data, time series, trajectories, data cubes on imagery. We got a little bit of that at the end as well. Open questions. So, it was very interesting to hear that throughout the discussions about edge computing and cloud, a very good use of object stores to support data access, but also then what do we do with computing that happens at the edge? In fact, the ISO committee that addresses this says cloud is computing. It may happen at the edge. And so you may see containers being really deployed at the edge. Video, one of the pithy quotes there was, MISB works great, but it has fundamental items that need to change in order for some of the future video analytics that we need. A lot of discussion about models, brittle bias and benchmarking, digital twins, patterns of life, lots of open questions about models that continue throughout the day. So next steps, entirely new classes of sampling strategies, the heterogeneous computing architectures with higher level programming interfaces that hide that complexity. We already do that with GPUs, right? But you have the whole set of standards for GPUs that make that possible. Mark gave us some other computing types that we need to have additional capabilities with. The relationship between digital twins and models for data science, we can explore that quite a bit. The deeper understanding of mobility and harnessing that mobile and LBS data. And then lastly, both in this opening session and throughout, I think we heard we should be looking at Jupyter Notebooks with respect to some way to develop, to promote development and reuse of workflows. We know that's happening across the community. What should a standards organization be doing with respect to Jupyter Notebooks to promote that? I think is an open question that we will take on. We'll do that next week. So that's what I heard. Session one. Is there anything that is glaringly missing? Partly a refresh, because you guys will walk away with a richer understanding of what happened. It's part for Trevor, because he sat out front the whole time and didn't hear any of it. So this is all for Trevor. You all met Trevor earlier. So that's what I have on session one. Session two.
Anything happening?
And you
Oh.
plugged it in.
I plugged it in.
You did plug it in. Huh? Vice. There you go. Now push.
All right, there we
something to
go.
make it is it that one there?
Yeah.
There we go.
So very, very briefly before I go into session two, for those who I didn't meet, I'm Annie Burgess from ESIP. For those of you that don't know what ESIP is, you all should since you came to this event. It's the Earth Science Information Partners. We work very closely with OGC. We're a community of data and informatics professionals. If you were ever wanting to say, hey, I work at a federal agency, wouldn't it be great to chat with people across federal agencies, private industry, nonprofit, academics, and just talk tech shop around data and metadata? We are your community. So esipfed.org. If you don't remember that, you could look it up, Earth Science Information Partners. All right. So this session was analytics and representations. Yolanda kicked us off and really focused on knowledge and models. And then we had this cross panel from Todd, Lauren, Rob, and Keith. Rob wasn't there. I was like, I don't think he was there. All right, so what works? Yolanda really focused on adding knowledge and how it enables more automated and less manual modeling. Another thing that worked was just the idea of provenance and capturing that provenance in model. And she noted that everything within her modeling has a URI to point to. And so that being able to explain models and have that is really critical and something that is working. Radiant Earth pointed out that they kind of realized that they needed a standard, and then it was that shopping it around, and really by bringing it to different communities, you ended up with a community vetted standard probably much quicker than building the standard and then just getting comments back throughout the years. So I thought that was another good something that worked. And then we heard from the SQL right here, and I think it was just another thing that worked was that the standards community hears what people are saying and that they evolve and build new standards based on what the community is bringing back to them. So I thought that was another good example of something that worked. Open questions, the idea of differentiating between prediction and knowledge and when it is okay for it to be a prediction versus knowledge. There's a question of what is ML data versus big data. And I think the very quick consensus, or maybe not consensus, but suggestion was big data focuses on the V's, but it can be unstructured and unlabeled, whereas ML data must be labeled and structured. So no one can quote me on that as a difference, but I think that was kind of maybe an open question. Always questions of ensuring quality of training data. We've touched a lot on this of what does it mean to build up a next generation of data science, how to maintain training data that has a temporal component, in other words, data that are changing over time. And then someone brought up sharing data with local entities, and just that at that kind of fingertips of the arm of government, that those people really need high quality data. And so are there different ways to share data with that crew? Next steps, compile training data that match the diversity of landscapes, for example, agricultural fields around the world, and other kind of changing geophysical entities. There was I can't be more specific than saying we need to work more on the raster side of standards. So I'll put that out to OGC. Also, I mean, Stack has kind of been peppered throughout this. I mean, it's fairly new, it's super fresh, but I certainly see, I mean, we don't need, that Stack will kind of continue to be in the conversation. And then, let's see, EO data in cloud-friendly formats. Again, the kind of cloud-optimized GeoTIFF, HDF, NetCDF discussion that will continue. And we ended with the idea of synthetic training data sets and kind of pros and cons, but more generally that there's probably a need for more domain-specific synthetic training data sets. So I would put it out again like George did. Anything that I missed that you think would be critical to add here? All right, 1, 2, 3, that's it.
Great. All right. And I heard a call for synthetic people. What I heard, all right. Why is this doing this? Session 3, Jacek, come on up. Push the right button, push the right button. Look at that.
I'm sure I missed lots of things, but I do my best to put it.
Introduce yourself.
Oh,
You've been here too long.
okay. My name is Kyung-Soo Kim. I'm also from AIST, and then I responsible for the OGC Geo AI doing, and also moving picture suite is co-chair. Now it's lots of work in OGC. So is the session 3 is live trends, and especially it's really interesting talk, and it's Philip gave us the AI at the edge. So I always think about the AI in the cloud, but he gave a different aspect. And then the panel, we have 4 great interesting talk, and more detail, the next slide. So Philip he introduced of the mapping of the information and customer necessary from to prove it for emerging technologies. He introduced lots of how to market survey, and especially he said is AI will be the game changer. But in IoT area, still is early steps. I really surprised that because IoT is more that, has some history nowadays, but still the market is not really increased that. But he expected that maybe 2021 or 2022, maybe IoT industry is become increased. And one of the key use cases he introduced of the transportations, I think the mobile smart mobility is one of the big target to combine of the IoT and the AI at the edge, I think. And what is the new requirements when we think about the AI at the edge and data security is one of the maybe is related to cybersecurity, and the bandwidth and latency is we have to think about that. And also, yeah, very interesting workflow, data flow. He showed that, and between the cloud and edge, we maybe that is very interesting. Yeah, the flow. So maybe we have to think about how can we support those kind of different workflow. And panel discussion is one is a skill set diversity, and so and also spatial temporal intelligence and situation awareness and cloud AI, especially cloud AI. They introduce lots of use cases for analysis of the imaginary video to detect of the change of the infrastructure after disaster. So I'm also in Japan. We have lots of disaster. I think sometimes it's a department store of the disaster. Yeah, but anyway, so we also very many people working on this area, and IoT data and privacy problem, and the last part AI can be us the manage of the data volumes and the determine value of the data at the edge. So that is kind of this panels give us this contents. And this is open questions. I don't want to read all of sentence, but what is the future of AI? And that times what? But we notice of the lag of the data. So I think it is especially I think the training data set. So for we have lots of data, but still it's not enough for training the machine, I think, and especially the hardware player. So in NVIDIA, he mentioned about the heterogeneous computing architecture. Now it's GPU, CPU, FPG, and Google is TPU. And so lots of now is computing unit comes up. So I think the hardware people also think about the more heterogeneous, the architectures. And also the meaningful safety project is responsible this disaster response. And this one is everybody cannot answer. Everybody said all of the things. We maybe need to combine in data science and AI. And another open question, because this is I just to put the date because we shared this question on the mail, and also but I want to share with you. And the next steps is first of all, how can we create value chain? So how can we think about the ecosystem is very important part, and how can we support of sustainable development? And another issue is geospatial data science education problem. So how can, what kind of skill we have to consider? So cross-disciplinary or convergence of each domains, and the communication skills for teamwork. So, and then, I also want to looking at the New York University. They have a good, education system for this area. And then when we need to retrain models, so maybe today is some people mention about the quality, but we usually discuss about the quality of the data. But now is AI people think about the quality of the models. So not only the performance, the accuracy, or some fairness or robustness, and then AI community peoples is start to discuss of what is quality of the models and how can support of that. Maybe, yeah, that is kind of a next step. And another things, because I'm a Geo AI doing, that's why I want to put, because whenever I mention about the Geo AI, and many people ask me, what is a Geo AI? So do we need a definition of the Geo AI? Or yes, okay. So now do we have to develop some definition? What is Geo AI? But anyway, I want to share the one of the things of definition of the AI. So this is not Geo AI, it's AI definitions. And ISO, the 1995, they is vocabulary, and they defined of the two definition of the AI. And recently, the JTC1, SSC 42 is artificial intelligence group community they developed the vocabulary. But I'm very surprised because the definition is a little bit different. And then to define the Geo AI, then what kind of things I have to refer. But anyway, I want to, discuss with you in OGC meeting. So please join the OGC-TC meeting. Thank you.
Session 4 is AJ.
What is that? This one. Is this it? Yeah, so yes. Now, look at that. Looking for the right one. Where is it? Everybody else is looking at that.
This one.
Okay. This should be HDMI.
Yeah, right there.
There you go. Yeah, I have them somewhere. There's so many connections I've never used on this thing. Yeah, I'll do it. Okay. Okay. Thank you, everybody. My name is Ajay Gupta, and as a previous rapporteur mentioned, want to put a plug in for the TC next week in Toulouse, France. I chair the Health DWIG, and so we are meeting Wednesday at 4:15 a.m. Eastern Time, 10:15 a.m. France time. But I do work at healthcare as our domain. We are a population health firm. We work with providers and departments of health or ministries of health to find solutions to reduce the cost of care. And we do that through geospatial analytics on health outcomes and healthcare costs. In America, we use Medicare data. We have access to the latest Medicare data from CMS, as well as all of the social and environmental data that we've been talking about today to find out why people get sick and stay sick and do something about it outside in the communities. So that's what we do. This session 4 on outcomes and applications, was I thought a really good session on why we can do some of these things. Wendy got us started with a really good overview of things that are taking place in the field. And Reagan, Megan, Stephen, and Ed talked about a lot of these kinds of things that are working in the field. And holistically, there was, I thought, a lot of overlap in what they were presenting, in that to get something that works, a geospatial application that works for a positive outcome, essentially starts with merging standardized data from disparate data sources that may come from government or one of many government agencies, could be crowdsourced, it could be field collected, or could come from private industry, and then can serve a broad spectrum of applications: road, rail safety, emergency management. Where OGC just did a pilot on emergency management areas, tracking of containments, public health issues, natural resource management, and logistics. There were, of course, open questions. And while this slide looks a lot less dense than other rapporteurs' slides on open questions, that's not to suggest that these aren't deep and nested questions, but questions of error modeling and bias. I think we've had a lot of discussions on how exactly we're going to address bias, right? And one thing that we can say on bias is, what does that mean?
bias as the term is itself not a negative term. We've given it a negative connotation, right? Because we associate it with discrimination and those kinds of things. But bias just means what's the inclination? So sometimes the bias may be positive towards whatever it is we are looking to identify. Where human knowledge and involvement can be in place, of course, there was, I think, agreement amongst the panel that human involvement in the use and development of models and the application of outcomes from models is important. But the degree to which human involvement should be involved is a question. The calibrated eyeball test or the sniff test that the panelists mentioned. And quickly, an example from healthcare is University of Oklahoma did an analysis of ophthalmological readings from an AI system versus actual physicians who would read these test results, and found that the physicians had an 87% correct accuracy rate. The AI had an 82% correct accuracy rate, right? So we're still better than computers. But when AI and computers were working together to identify and diagnose diseases of the eye or the retina, it was a 93% rate. So if we work together, man and machine, we can certainly be better. So human knowledge is not necessarily replaced, but augmented. Data retention, curation, the medium, and stewardship, all of that is an open question, as is ethics and privacy. That came up in all of the sessions. What are we doing with data? Are we gonna give it and make it openly shared? And how much privacy do we really need? And if we have so much privacy on data, is it going to be available for the work that we want to do and the research that we want to identify? And next steps. Obviously, the next steps is to address some of the open questions, right? So that's clearly there, but there's certainly need for more standards on data and data collection, and for those standards to be balanced against potential risks to innovation. But the panelists did mention a number of places where innovation has led to standards has led to positive innovation in a number of different fields. So the right standards at the right time is certainly a model that we can follow. Model validity itself is an area for next steps, and communication on the model and machine learning, right? That it is, again, this is a quote from the panelists, not a human replacement, but a force multiplier. And as was mentioned earlier, there's probably stuff and content that I've missed. If there was anything that I missed, please let me know or let George know so we can put it into the final report. Thank you.
And now the tough one, the guy that had to do the summary of something that just happened, right? Adam. Have you been introduced yet? This guy's been involved. There's been a few people. Patrick was involved from the beginning. Adam was involved from the beginning in terms of getting stuff together. Who else was on our 6 months ago kind of coordination? But he's been there the whole time. I really appreciate all the help.
Sure. My name's Adam Martin. I work at Esri. My other colleagues had to catch a flight, so I apologize for their not being here. And then I press what to get the screen going? Presenter cam. Huh? Local present input. Ah. Yes. Great. Okay. So you're still here. Thank you. Yeah, I won't spend too much time since it's all somewhat fresh, but what I heard from our speakers is that government investments in infrastructure are working at some level or are starting to work to accelerate the use of AI, both in Japan and in the European Space Agency to help with experimentation and providing better Earth observation products, and continuing to drive to provide more analysis-ready data. Continuing to move up the value chain from bulk downloads in random formats to usable services available through APIs, et cetera. So that was a big theme. Starting to actually use AI to impact real world policy compliance efforts and in the agricultural sector in the EU. That was a great example, which I think is ultimately the aims, right? And what are these problems that we're trying to solve? In this case, the value chain is super large, lots of capital investments in terms of satellites, for specific purposes. This is one of the outcomes that somewhat drove those investments, as well as are helping to reinforce the value and the ROI of some of this data. And so the more we can implement that, the better those kinds of practices. A lot of discussion with our university and local government panelists around and NGA, how to train data scientists within your organization, and doing that partly through this hub and spoke model, understanding where you are in the solution design landscape and process, but ensuring that it continues to be a team sport, and that you're getting a diversity of perspectives, and partly doing that through partnerships, both with university and in the community. So we heard about the Data Science Federation and the growth of that partnership with universities to tackle actual problems that local governments had, as well as the Data Science for Public Good program at UVA that's also scaling out. So it seems to be a good model, and that points to, I guess, some of the other next actions, which is essentially keep convening across these sector boundaries. Yeah, open questions. You just heard some of them, right? Just a few minutes ago. What are the standards we need for training data, reference data? How do we make sure that whether it's the stack spec or others, these specs allow for easy exchange and exploration across our different national government investments? Are there existing codes of ethics or value statements, Bill of Rights, et cetera, from LA that we can adopt as a community or shape? I'm sure they're out there. We don't need to reinvent the wheel. But what are those that we should adopt? How can we lower the barriers for private sector data sharing, especially for the research community? Not to call out CoreLogic, but sorry, these are fresh notes. I just copied and pasted in there. And then how do we accelerate, the population of metadata that came up in some of the conversation, and that stuck out with me because I'm actually working on a project at Esri to enhance metadata management and search functions within our ecosystem. So I'm very interested if people have good ideas about ways that the software can populate metadata in a formalized way, because that's what we're looking at. So the next steps, similar things, right? How do we ensure that Jeannie brought up specifically like data licensing and making sure that those are standardized and adopted throughout the web, so that we can generally find those easier, because we've heard that a lot at Esri as well. Is like, hey, great, you have open data, but I can't easily find which ones I can actually use, which ones have the right license types that allow me to use it commercially or what otherwise. And so we've actually been working on that for the data that flows through our system, making that more available, but there's still a need for that to propagate throughout the web. And yeah, keep convening, OGC doing what you do well, which is bringing industry and academia and local government, federal government together to tackle these problems. Thanks for doing that.
All right, so, well, we're almost done. Last steps. If you presented something, please send it to me, including the ones that you just presented and the like. Please send those right away because I got to report out next week. So the video, we've been recording video and the like, and Ed's got that one. It's going to go up on YouTube. The video and the presentations will be linked back into the webpage where you saw the agenda and everything for this. Lastly, we're going to generate a report or a white paper, builds off of what you just heard from the summaries and other stuff, and gets us to the recommendations that we ought to carry forward. So that's kind of what's going to happen coming out of here. So in terms of thanks and thank you to folks involved, the panel that I mentioned a few minutes ago, the organizing group that I presented the names at the very beginning of yesterday, and they're on the website as well. Ed, thank you, buddy, for Thank you to Google for sure, but thank you to you personally. So he's British. I'm going to embarrass him just by thanking him, right? And thank you for coming and participating and being involved here, because that's really what made it work, is your involvement and the like. So I will, of course, leave it for the last word to our CEO. So.
Because I think there's one big thank you that we owe to George, because he's behind all of us actually being here. So thank you. And we can't do better than this to show you what OGC is, or actually who OGC is. So if you're not familiar, we're here. Talk to anybody, get engaged. I second everybody who said we need to convene some more. So thank you again for all of you, and really thank you, George, for putting this together as part of our future-looking tech trends activity at OGC. And safe flights, everybody. Thank you.